So the equation was 9x squared minus 12x plus 4 equals negative 3. So then I got 3x minus 2, and 3x minus 2 equals negative 3, and then I square rooted it on both sides. Then I subtracted the 2, and I got 3x equals 2 plus or minus I over square root of 3 divided by 3. And then I got x equals 2 plus or minus I square root of 3 divided by 3.
So number 11, she has it factored. It becomes that perfect square because it's 3x minus 2, 3x minus 2. So that's a perfect square pattern. Take the square root of both sides. The I comes out because there was a negative 3. Nice job.
Okay. Wait. Okay. So I.
All right. If you look at number 27 from the homework.
Okay. So I did number 27, and the problem was x squared minus 2x plus 25 equals 0. So to solve for x, you first have to subtract 25 from both sides, so you can find what makes it a perfect square trinomial. So you get x minus 2x plus 1 equals negative 25 plus 1, and then you can simplify that to x minus 1 squared equals negative 24. And then you go ahead and you square root both sides to get rid of the squared sign. And it equals x minus 1 equals plus or minus I times the square root of negative 20, times the square root of 24. That's a typo. So x minus 1 equals I square root of 4 times square root of 6. And then you can simplify it to x minus 1 equals plus or minus 2, and then I times square root of 6, and then that'll simplify to x equals 1 plus or minus 2I to the square root of 6.
Any questions for Dylan on number 27?
Favorite color?
What's your favorite color? What did you
Green.
say? Green. I thought you said gray.
What's your favorite color?
Ooh, same here.
My favorite color is I have two favorite colors. Black and white.
My favorite color is red.
I'm not sure.
Maybe the color of your
Okay.
You have brown eyes, raise your hand with one pinky up there.
Kate.
Just the gap.
What?
Hmm?
Oh, I did that.
If you have blue eyes, raise two thumbs in the air.
If you what? If you what? If you what?
You're not sure. Hazel? Is that what hazel? I don't know.
Yeah,
Hazel.
if you have hazel eyes, put one I have a couple.
If you have green eyes, pick your nose with your tongue.
Ew, Can you?
No, I have brown eyes. If your name is Julia, jump off the cliff. Oh yeah, you are.
Oh, what a dumb joke.
Oh, sick.
Oh, okay. We talked about this. So, okay, real question. Is it black or white?
No, just leave you
You
on.
can wear a black dress and I'll wear a white suit.
Oh, I like that.
Yeah, that. You could do that.
We're doing that.
What?
Wait, so did you get back together? I'm confused.
We were never together, we were just planning.
Alright, in your notes, I will turn to page 31.
You have to find your signals.
I'm there.
You're already there, Ethan? Already on 31?
Yeah.
Overachiever.
Alright, so if you look at example 4, so still completing the square, what do you notice different with A and B in example 4 compared to the homework problems as well?
There's a 3.
Yeah, there's a 3 with the x squared. So when we talked about factoring, the first way we started to factor was just like x squared plus 3x minus 4. So we started factoring with the regular AC method when nothing was in front of x squared. And then we changed that and we said, all right, now we're going to factor if we have 2x squared minus x plus 15. And then that was the AC grouping method. It became a little more involved because we kind of applied a different value in front, so that changes the factors. So in these problems, kind of similar, we started out yesterday with using the completing the square with just an x squared, and then we try and build on that because not every problem is just x squared. So if you look at letter A, we have 3x squared plus 12x minus 27 equals 0. How do you think you'd try and start a problem that's set up like this?
Take out
Yeah, we could take out a 3. So, Savannah, if we took out a 3, what would that be?
3 times x squared minus 4x minus 9.
So she said take out a 3. You get x squared minus 4x minus 9 equals 0. What else would you need to do then? Brandon? So we can't subtract 9 because it's in parentheses.
Ooh.
So let's tweak it a little bit. Instead of taking out the 3 from everything, what do you think we should do then? So let's take the 27 to the other side first. So that C value, you're going to want to eliminate that number first. Take it to the other side. Because that's the value that you can't use when you're completing the square with. So we need to get that number to the other side. So we'll take 27 to the other side first. And then what could we do?
Divide by 3.
Yeah, then we'll divide by 3, and it does become 9, but we need to make sure that we're like doing correct algebraic steps. So legal algebra. So now it is a 9. So if you take the 27 to the other side and then take out that 3, you can kind of do it in the same step. Or you could also thought like, let's just divide everything by 3. Maybe that's another way you wanted to think about it, dividing everything by 3. So now we have x squared minus 4x. And it's equal to positive 9. So now it's ready for us to like complete the square. So what are we using to complete the square, Scott? What number are we using to complete the square? 4. So we've got a negative 4 divided by 2 and squared. What does that give us?
Okay.
Yeah.
4.
Yeah, so that makes 4. So we do that. This is b. So you're taking b divided by 2, squaring it. So b is now negative 4, not what we started with, but what we have now after we took out that 3. So that gives us a positive 4. And then here's the piece that it looked like some people were forgetting. If you're putting a positive 4 on the left side of an equation, because it's an equation, whatever you do to the left, you have to do that same thing to the right. That keeps the equation balanced, equivalent to each other. So don't forget to add that extra 4 to the right side as well. Some people are forgetting that piece there, and they're just placing it on the left, but not kind of correlating the value to the right. So Ethan, x squared minus 4x plus 4, how does that factor?
That would be 4. Wait a minute. 2 and 2, negative 2, negative 2.
So x minus 2
Squared.
squared and 9 and 4 make
13.
13. So the completing the square part is done. We took the c to the other side, we used b divided by 2, squared that number, that became the value that completed our square, added the value to the other side, and then we were able to get it factored. So we have x minus 2 squared equals 13. So to solve it, now that we have a squared term, we can take the square root because they're opposites of each other, so it cancels out the square. 13 is prime. It doesn't have a perfect square. It's only 1 and 3 that make 13. Sorry, I don't know how that became 3. Sorry, I saw that. So it's just the square root of 13. So Chelsea, your answer would be?
X equals 2 plus or minus the square root of 13.
Right, 2 plus or minus the square root of 13.
Pause.
Any questions? So really, we didn't do much different there. We just made sure to get the 3 out of the problem. But really, we still solved it in the same manner. Questions? So if you look at letter B, it's kind of the same process. We have 3x squared plus 36x plus 150. So either think that you've got to divide the 3 out of everything, or if you take the 150 to the other side, pull the 3 out from the left, and then you're dividing it after it's on the other side. Either way, you pretty much get the same answer. So we divide by 3, we end up with x squared plus 12x. What's negative 150 divided by 3? Negative 50. So now we want to complete this square. So we need to get the number that goes on the left so that it becomes a perfect square, and we also need to add that same number to the right. So Luke, what number are we adding into the problem? 36, yeah, because you're taking 12 divided by 2, squaring it. So 6 squared is 36. And then Luke, how does the left side factor? And on the right, we have negative 50 plus 36, negative 14. Any questions getting to that point? So if we take this square root, Isabella, what does your answer become?
X equals negative 6 plus or minus I in the square root of 14.
Awesome, nice job. So there's a negative underneath the square root. That negative creates the imaginary number. Don't leave it underneath the square root. Pull it out, make that imaginary number. The square root should have a positive number left underneath. So we have negative 6 plus or minus, and then I square root of 14. Any questions with either of those two examples? So the third question, not really third, how about the fifth question, but the problem at the bottom is a little different. It says write a quadratic function in vertex form. So just going back to the two problems here. What form, if we were graphing a parabola, what form is this currently in? What's that form called? Standard form. So standard form is ax squared plus bx plus c. And we use the formula negative b divided by 2a to find the axis of symmetry. You take that number, plug it in to get the vertex. So for your chapter 4 test, you won't be doing all of that, like graphing it, working through the whole problem, but you'll still have to remember how to find a vertex and use that information. But we can take something that's in standard form and change it to vertex form. And sometimes it makes it easier to actually find the vertex form than it does to calculate negative b divided by 2 and then go back and plug that into the problem. But what is vertex form? Like, what does that look like? So standard form is ax squared plus bx plus c, but what's vertex form supposed to look like? Cooper, do you remember? No? You weren't raising your hand. You did, oh, that was a don't know, I gotcha. Brendan, do you remember what vertex form looks like?
Y equals the coefficient A
A,
parentheses x minus
H. Yep, you're good so far.
Plus K
You're so close. What are you missing in there?
squared.
Squared, yeah. So vertex form is the H and the K form. So H and K are the vertex, so if we can get something into vertex form, then we can quickly find the vertex. Well, completing the square looks really close to vertex form. Like this right here, before we take the square root, is really close to being vertex form because we have this thing squared, we just have a number on the other side. So if we look at the problem here, we have y. It's y equals instead of 0 because we're not solving for x. We want an equation in vertex form or a function in vertex form. So y equals x squared plus 14x plus 44. How do you think you'd try and get that in vertex form? Using completing the square. So how can we try and get that to be vertex form? Libby, what do you think you'd do first? What do we do first with the other problems?
I would find the greatest common
So before that, what do you have to move?
factor. Oh wait, move 44.
Yeah, so this 44 isn't a perfect square. So that's the C value that we need to take out of the problem or move to the other side so that we can complete the square. Now, the only difference with this problem is the y stays in the problem. There's not a 0 there because you're not solving. So the y stays in there, and now we have y minus 44. When you complete the square, now it's on the right side instead of being on the left side because the y is on the left. But we still have that x squared and the 14x. So kind of the same thing, but there's an extra y in the problem because it's an equation, it's not equal, or it's a function, it's not an equation equal to 0. So what would you do next to complete the square? Brandon?
You divide 14 by 2 and then square it to get 49 and add 49 to both sides to
Good.
get.
Okay, whoa, just stop. Too much. Take a little breath. So you take your b divided by 2, that's the same process we've been doing. So that's 7 squared, which is 49. And as he said, you need to add that to the other side. And then Brandon, on the left, you end up with
Y plus 5.
y plus 5. So adding negative 44 plus 49, y plus 5. And on the right, it factors to
X plus 7 squared.
x plus 7 squared. So vertex form, y is supposed to be by itself, which if we just take the 5 to the other side by subtracting it, then we have x plus 7 squared minus 5. So the a value is really a 1. That means our parabola is just a standard parabola. Figures are a, h, k. So it's in that form of the vertex form.
I'm so bad.
You don't like vertex form?
No, I'm just bad at
You're the completing the square part?
math.
No. So how do you find the vertex? Chelsea?
Isn't it just H and K?
Yeah, it's just h and k, but what do you have to remember about h, Chelsea?
You have to change the sign.
Right, you have to change the sign for h. So h is really negative 7, k is negative 5. And then Chelsea, the axis of symmetry is
-7.
negative 7. It's the same x value of the vertex. So this is a different way of finding the vertex by starting with standard form, but then changing it to get it out of that standard form so that it's in vertex form. I don't know if one way is easier than the other. It's kind of just what you prefer. I like completing the square, like factoring. Chelsea likes factoring. Maybe you like completing the square too, huh?
Oh my gosh.
My foils.
Any questions? All right, so if you flip the page,
Yeah, I'm not
I'm not good enough for this.
Poor Julia.
It's alright, I guess. You can't foil to our standards and you can't be
so in example 6, we always have to throw in a little word problem to every section. You don't like word problems?
No, it's not higher. I'm
Oh.
on the
Do you play baseball, Ethan?
I did when I was younger.
Okay.
Yes.
Do you play on, yes?
Yeah.
On the team?
Yeah.
Oh,
Yeah, Cooper's a baller.
really?
Yeah.
Huh. I'll have to ask Mr. Long about you then, huh?
He's gonna have a lot to say about me.
A lot to say. Oh, then I might have to ask him tomorrow morning. So baseball, maybe I shouldn't. Is that what you're saying?
You might want to. That'd be interesting.
So the height y in feet of a baseball t seconds after it's hit is given by this function. So y equals negative 16t squared. This negative 16t squared, that's the part that's due to gravity. So when we did the dropped object model, gravity is affecting the rate that an object drops. So that gravity, that negative 16t squared, that's that gravity number. So it's really 32 divided by 2. It's negative because gravity slows things down. The middle number, the 64t, that number is based off of how hard the ball is being hit. So Cooper hits a little blooper, and that number would be smaller. And it also is based off the angle that the ball is being hit off the bat. So that's what this number is. That number will always be given to you next year when you learn sine, cosine, tangent, and all that trick stuff. You'll be calculating that number, so you'll see why that number is created. The last number would be the height of the bat when the ball is connecting with the bat. So the height of the bat is at 5 feet above the ground when the ball makes contact with the bat. So that's like kind of where those numbers are coming from, just so that you're not like, oh, it's a random equation that's being given to you. Again, you won't have to create the equation, it'll always be given. But at some point, whether you take physics or trigonometry, you will be creating equations like that. So our goal is to find the maximum height of a baseball. So if a baseball is hit, what shape does it make? What shape does the ball travel?
A bump?
A bump, an arch, or
A rainbow.
a rainbow, a parabola.
Oh, parabola.
Yeah.
Oh.
The max of the parabola is what part of the parabola? The top, and what's that called?
The vertex.
The vertex. So the max is equal to the top or the vertex of the parabola. So if we can find the vertex of the parabola, then we would know what the maximum height is of the ball.
What if you had a ground root? Then wouldn't it be
Yeah, then it would be then it would be
minimum?
the opposite. It would exactly. It would be
It would
the,
still be a parabola.
it would still be a parabola. Yeah.
It's like it get bounced off.
All right, so we're going to see if we can take this negative 16t squared plus 64t plus 5 and try and find the vertex by using the vertex form. So we're going to see if we can use completing the square vertex form to get the maximum height. So the first thing that you need to do is subtract c. So the value of 5, we need to take c to the other side. That's the first step in any problem. Get rid of c if we're trying to complete the square. So we would have y minus 5. On the other side, we have negative 16t squared plus 64. T. So what do you think you do next? Brandon?
Divide by, take out a negative 3 and a negative 16.
Right, so we need to take out a negative 16 because right now there's a 16 with the t squared. And you're not allowed to have anything with t squared if you're trying to complete the square. So we're going to factor a negative 16 out from the right side. And Brandon, if we pull out a negative 16, we still have t squared. What's 64 divided by negative 16?
Negative 4.
Negative 4. And that goes with a t. So we cannot divide by negative 16 because if you divide by negative 16 on the other side, you have y divided by negative 16 and 5 divided by negative 16. And that makes a really messy problem. So we're going to keep the negative 16 in the problem because it doesn't divide evenly like the other ones did. So we're just going to keep it out front there. We're still going to continue to complete the square. So inside right here is my b. That b is negative 4 because we pulled out a 16 from that value. So negative 4 divided by 2 squared. Julia, what is negative 4 divided by 2 squared?
2 or 4.
Right, so it's 2 squared, which she said was 4. Now here's the part that's a little different. The number that goes on the other side is not 4. Because what's in front of that 4? A plus sign. But what's at the very front of the parentheses? The negative 16. So this number really isn't 4, it's negative 16 times 4. Even though you're plugging a 4 in here, really that 4 is affected by the negative 16. So the number on the other side is negative 16 times 4, which is, I had somebody whisper it, negative 64. So that would be like the little difference with this problem. Because we couldn't divide the 16 out, we had to keep it in the problem, but it affects the number that you're placing on the other side. It's not just a 4 on the other side that we need to place over there because it's really a negative 16 times 4. So now on this side we have y minus 5 minus 64, so y minus 69. That negative 16 stays in the problem. We're not getting rid of it because you can't divide it out if it doesn't divide evenly. And then how does the middle factor? How does that parenthesis factor? So, Dylan?
T minus 2 squared.
T minus 2 squared. So Dylan, if you put this in standard form, what would it look like? Or I'm sorry, vertex form, what would it look like?
Y equals negative 16 T minus 2 squared plus 69.
Perfect. So the negative 16 is the A value. That tells me my parabola gets really skinny if we were graphing this. And then you have your H and your K. So the vertex, we said, was equal to the maximum value. So our vertex is 2 and 69. How high then does the ball travel? What's the highest position that the ball is located at?
69 feet.
Yeah, so 69 feet would be the height of the ball. That's the max height. The 2, that's your time. So after 2 seconds, the ball will be at its maximum height, and then it's going to start coming back down until it hits the ground. So the 2 is the time that it takes. It takes 2 seconds for it to reach the maximum height of 69. Questions? So if you go to the last problem on the page, I want to do one more just so that you kind of make sure you're okay with working with the number in front. It's the same exact problem. It's just now there's an 80 in here. So that means Cooper's hitting the ball harder this time than he did the last time. So maybe it'll go further. So 69 feet seems pretty high for a baseball, but what happens if we change that to an 80? So take the 2 to the other side. So y minus 2, eliminate c. So we took the c to the other side. Factor out whatever's in front of t squared. Well, there's a negative 16 there again. You're only taking out the number, never a variable, because we need to keep that t being squared so we can complete the square. Does anybody know what 80 divided by negative 16 is? 5. So then we're taking b, which is negative 5, divided by 2 squared. Yesterday we did a problem where we had fractions, and that's okay. So when you square a fraction, square the top and square the bottom. So Julia, negative 5 over 2 squared is?
We'd multiply the top, right?
Yep.
So I squared root of 10.
So just square both of them. So what's negative 5 squared? What's
25 and 4.
There you go, 25 and 4. So somebody with a calculator, we now have to put the number on the other side, but it's going to be a nice number. It's not going to be evil. What's negative 16 times 25 over 4? Turns out nice. Anybody know? Brandon?
400.
Did you divide by 4?
Oh, wait, no, I didn't.
100? Oh, and it's a negative 100. So then we have y minus 102, the negative 16. Does anybody remember how this factors? So remember, you're really just taking the square root of this number to plug it back into the parentheses. Savannah? Right, t minus 5 over 2. So it's just the square root of this number, or it's the value that you had before you squared it. So that's t minus 5 over 2. So our equation, negative 16, t minus 5 over 2, so that's the time, 2.5 seconds, and then plus 102. So how high did this ball go? So this ball went 102 feet. Questions? So you can do that problem using negative b divided by 2a, but you can also do that problem with the completing the square. So I have a little quiz. I'd like you to do 3 of these 5 problems. You pick the 3 you want to do.
If we do more than 3, do we get extra?
No. This is on factoring. I don't want the factoring to like be totally erased from your memory. So 3 problems. You pick 3.
So a regular factor?
This is regular factoring. So just plain old AC grouping, factoring, regular factoring. I don't want any of this to kind of disappear just because we're completing the square, because we're taking square roots.
How many of these do we get?
3.